That was a big challenge, and it's still a big challenge. There was nothing that we could buy over the counter. So we can run 64,000 load flows in 5 hours. The distribution grid is right now in the spotlight, I think. We're trying to build pipelines to other systems that already have great information and share that. We need to make sure customers' data is very secure. Obviously, everybody knows at some point change needs to happen, and continue your journey because new technologies come in. Even the seasoned engineers have to adapt to new technology.
This episode is brought to you by Qualitrol, the leader in condition monitoring. Qualitrol is driving innovation that keeps power systems smarter, safer, and ready for the future of energy. So my guest is Steffen Ziegler. Steffen's with Eversource. You've got a leadership role in system planning. Steffen, you and I have known each other for many years as friends, as colleagues in the industry, solving problems together. But tell me a little bit about how did you get into your current role, leadership role in system planning at Eversource? And then for those that don't know you so well, give us a little background how you got to this place and this role.
Yeah, thank you, Ben, for having me here. As you said, we know each other since a long time. We worked together in the previous company I worked in reliability for underground distribution and transmission systems. A wonderful technology. After 20 plus years, I changed to Eversource in system planning. All the knowledge acquired in the previous job is very valuable for me in my current role in system planning. Currently, what I'm doing at Eversource in system planning is I'm leading a team of engineers in the advanced forecasting and modeling team. We are responsible for modeling the grid, not as it works just today, but also how it will work in 5, 10, 15, 20 years. Obviously, there are lots of things changing on the grid with distributed load, distributed generation, as we all know, and we have to make sure investment is being done prudently and the investment is targeted so the grid can function and safely, reliably, affordably serve people in the future.
Right. So obviously you're passionate about serving the industry. You've been in the industry for a long time. Even when you were started your schooling in Germany, and I think you even worked for a German utility. So you have international experience, and you've been passionate about the mission of utilities for that, like you said, safe, reliable, affordable, and resilient grid. But now you're thinking about the future. You're thinking about how to create that grid of tomorrow. So what are some of the challenges that you're facing? And tell us a little bit about what does system planning mean to you and the team that you're leading?
Yeah, that's a great question. So system planning deals a lot with power flow conditions of distributed generation that everybody knows, such as photovoltaic panels, like the small rooftops, all the way up to the 5, 10 megawatt ones that we have in New England. Eversource serves New Hampshire, Massachusetts, Connecticut, our largest utility company in the Northeast. So there's a lot of distributed generation implementation, but it doesn't stop just there. We have in Massachusetts, for instance, heat pumps that are being mandated for certain buildings,
right?
And they make a very big impact on the grid, as you can imagine. Cold temperatures, such as coming up in the next couple of days here, will make heat pumps run like crazy. So the electric load is significantly increasing.
Okay.
We already know from our calculations we're going to a winter peak by 2035. It's not the traditional summer peak anymore. And as you can imagine, reliability is a very important factor. People who rely on electrification, they cannot lose power in the winter. That's a much more detrimental scenario than if that would be in the summer. So reliability, power flow, making sure customers can easily connect load or generation, all of these things are being considered in system planning.
So tell me a little more about system planning and the challenges you're facing. So how big is the challenge? How much of load are you looking at? Like we said, in the next week or so here, this is being recorded in January 2026. We're expecting some very frigid temperatures across the U.S. So the issues that Eversource is facing is going to be something a lot of utilities. But specifically, when you're thinking ahead and you're thinking about a winter peak, what are some of the things that you have done, some of the challenges that you've faced and solutions that you've implemented? Can you tell us some more detail about that?
Yeah, I can give you certainly a few details. Distribution substation where the transmission system comes in and the transmission voltage is being stepped down to distribution voltages, those are key, right? Those are the, let's say, main feeding points for what customers experience. So distribution substations were built in the last 50, 60 years in certain cases. With the current load and generation conditions, they become very, very small compared to what is coming up in the future. So we have to think about upgrading substations, upgrading main feeder lines. However, that costs a lot of money. As we know now, a transformer or wires nowadays cost a significant amount more than they did 20, 30, 40 years ago. So we have to think of this not just as upgrading where necessary, but also how can we upgrade it in a smart way that we spend our money prudently. We have the budget and we have considered all the alternative options. So system planning is calculating alternative options, scenario-based capital upgrade plans, and that involves also reliability studies, right? We don't just want to upgrade the grid without considering reliability, resiliency. That's also in system planning, a very specific team within system planning we collaborate with. And then obviously forecasting and modeling. Forecasted information is key. And as you know, there are lots of possible scenarios, what the future could hold for us. So we're trying to probabilistically determine certain scenarios, but do not exclude certain scenarios. So we probabilistically model the grid of the future.
So can you give us an example of, do you look at it, so you said by substation, do you look at a specific circuit and say, or a specific substation, or maybe two substations? Are you looking at a region? Like, how does this process start? And take us through an example of, you don't need to mention area names and so forth, but substation A, substation B, so to speak. How did you make those decisions, and what tools did you use to figure that out? You said probabilistic. I'm interested.
Okay, yeah, I can give you a little more detail about that. So first of all, substation upgrades means you go to the same substation. You do not have to expand the substation and go through the whole zoning and process, which takes quite a bit of time. You go into substation and replace transformers, right? That you typically upgrade transformers. And as you know, there has to be some contingency in case one transformer fails on a bank. Another one needs to be in there. So the cost is always more than it's needed because of contingency, which means backup considerations.
Correct.
Sometimes we have to think about new substations, load centers that do not exist yet, but due to new construction, new commercial buildings, new ways where electric vehicles will most likely be charged in the future, or electrified bus stations. All of those aspects determine where new substations would need to be built.
So where does that input information coming from?
Yep.
Do you have, like, you taking polls from different people, or you're interviewing people, or when people want to do things, are they sending you a letter? How does that work?
It's a very good question. So the information comes from public databases, census databases even. We can also forecast and predict certain behaviors. Let's say electric vehicle adoption, like where do most of the electric cars charge from? Where put people most of the applications in? Where do businesses apply for large loads? That's another indicator, right? If commercial businesses build in a certain area that is advantageous for them, we find that out through various commercial databases, or publicly available information. And then other things we have to geospatially forecast, right? Where we don't really have any source that would be deterministic. That's where we have to look at the landscape and build models. So we model the propensity and the adoption of load and generation. So with that, again, the further out you look, the less likely you will hit the exact target, how it will be. So that's why we consider a probabilistic distribution of those variables. And as soon as we talk about not having one stand-in scenario, but many different cases that we have to consider, the amount of processing and calculation significantly increases.
Okay. So you have public databases, you've got people making applications, you've got all of these input, and even then you know that there's some error in that input, right? You're not going to get it right all the time, so you're making probabilistic. Is that something you've developed on your own, or is there tools that you're inputting in? Like, tell me about what are some of the solutions that you've found to help bring all this together.
Yes, that was a big challenge, and it's still a big challenge to use the most out of every tool that system planning has. Some tools run more in isolation than in harmony, so we have to integrate some of those tools and workflows. When it came to probabilistic load flow, there was nothing that we could buy over the counter.
Okay.
So there's really no offering that fulfilled the requirements that we had. So what we had was actually a great load flow solver from a company called DNV. And that load flow solver can be integrated in an environment that is a computational environment, can be controlled from the outside. And that environment is also allowing us to probabilistically model load and generation based on certain probability density functions that our forecasting team calculates. So we can actually take a normal load flow solver engine and pack it onto this probabilistic layer and then start running hundreds of thousands of load flow scenarios.
Hundreds of thousands of load flow scenarios. Where are you doing all that calculation? That in your PC?
No, unfortunately, that is the challenge, right? You have two options, right? You can go to a cloud-based environment, but as soon as you go to cloud, cybersecurity becomes more of an aspect again. Or you can do on-premise calculations, and after doing the math of what it would cost to run these probabilistic load flows, we found out it's actually cheaper on-premise if we buy a very specific machine or machines that we have that have the right hardware and have the right integrated development environment on it. And that actually worked out very well for us. So we can run 64,000 load flows in 5 hours, for instance, which is a very significant step forward, considering that a few years ago at Eversource, we ran one scenario after another on individual laptop computers. So this is one step forward into productionizing and large scaling the load flow capabilities.
Fascinating. So I'm just curious, do you happen to know, and maybe this predates you, but like how long would it have taken to do one calculation some time ago, and now you're doing 64,000 in 5 hours?
Yeah, it's a combination of improvement in hardware capabilities. Nowadays, you can buy computers that have CPUs, central processing units, many of them, and in combination with GPUs, graphical processing units, which lend themselves very much to specific linear operations or linear system solving operations. And they come more or less from the gaming industry. The gaming industry 10, 15 years ago drove all of those products, which are now used in machine learning, deep learning, but they can also be applied to solving grid calculations, linear systems, or matrix solving. So these machines are a perfect fit. So it's the right timing now to apply grid modeling to those very powerful machines.
Wow. So did Eversource already have those machines before you came, or and you were able to use them, or were you part of that investigation of which machines to get, or how did that work? Because I know sometimes going into a new using new technology and building equipment or buy versus rent versus cloud, those are very difficult conversations and difficult to make decisions to help solve a very known problem, right? You knew you had to make more calculations per unit time, so to speak, right? To be able to identify which way to go with these investments. But you had to convince somebody and any sense of how that went? Was that predating you, or is that?
No, there was actually an initiative that my team and another team, a great colleague of mine, started when we thought about how we would best implement a regulatory requirement, which was capitally funded. So we had some budget for that.
Okay.
So we thought, how can we do this best that will be a solution that we have control over and will serve our clients
Right.
indirectly by these calculations and will be used and useful. So what we did is we selected those machines after speaking with our IT organization. First of all, we wanted to make sure we comply with security and make sure we are not doing anything that can be considered a shadow project. So we wanted to make sure this is a long-term solution that the system planners, the group that I'm working in, and a couple other teams have control over. And then we found the right combination, purchased that, and built it up from scratch. But I have to say, the company with the load flow solver was very cooperative. They helped us to integrate that load flow engine in the environment that we're using. It's a MATLAB environment. MathWorks is actually supporting the parallel processing of all of these load flows and the integration of that tool. So we use the power of both worlds here, the experienced load flow solver with a very mature computational tool. And long and behold, our team has full control over, which is a very important point in the utility company. If you buy over the counter and you don't know what you have and it's considered quote unquote a black box, every time something goes wrong or something needs to be changed, you cannot do that. In that case, with the probabilistic load flow, we have complete control of our source codes. We can completely further develop the system, and there are already new requests to make this further useful on other fronts.
Wow, that's great. So that's already a major success, right? To be able to do that many more calculations in that per unit time. Can you give us a sense of like a little success story about maybe what you would have anticipated, what they would have had to do years ago versus what you can do now, or maybe even a specific case where you were able to find the right capital solution that so that you're able to move forward confidently. Can you give us a sense or a little example?
Yeah, I would say 10 years ago, that would have been very difficult to stand up. First of all, the hardware was not ready yet. I think the computational environments were not capable enough to parallelize such a process. And engineers that would have been asked to code such a thing would have been rare. Nowadays, every engineer coming out of an engineering school has coding experience. They are considered subject matter experts that can actually implement some of the code themselves. With the existing AI tools available nowadays, that is even more of an accelerator that engineers can actually handle rather complex solutions. So that's another factor why this is a great time to work at a utility company and solve challenges that have been longstanding, like high hardware capability, AI capability to help coders, and also software that is able now to crunch through the grid, not just calculating power flows, but as I mentioned before, reliability studies, contingency studies, fault studies, all of that is now integrated. And we see the picture emerging that in the next few years, we have an all-encompassing environment that can actually be handled by engineers to get answers rather quickly that help investment decisions, right? An investment decision is a very difficult decision because it considers not just the technical aspect, sometimes it considers customer perception, it considers reliability, has to comply with regulatory constraints, and all of that can be modeled in an environment that is now easier to handle than it would have been 10 years ago.
Wow. So are there cases where you're deciding not to upgrade certain substations because of your probabilistic? So you thought, hey, this is the one we should upgrade because this is going to be the bottleneck. But then when you actually did the calculation, you said, you know what? That's not the one. This is the one. Or have you been surprised at some of the outcomes? Has there been cases where it hasn't been so obvious to begin with and now provided some clarity or even some confidence to go in front of, say, regulators and say, we believe this is the right path based on this evidence that we have?
Yes, so we found quite a few cases that were not necessarily a use case, because we tried first on cases that we can just hypothetically go through. But in any event, the cases that showed up had very clear, distinct points in the grid or regions in the grid that showed specific issues. We call them utility violations. A violation is either a voltage issue where voltage goes out of bound, or thermal violation, overcurrent, reverse power flow. All of these things we call violation. And we would not have expected certain violations with stand-in modeling, the traditional way where you consider maybe a handful or a dozen scenarios, right? Hand-picked scenarios where you as an engineer think those are the ones that are probably the extreme cases we have to consider, but they were not part of the, let's say, hundreds of thousands of scenarios that the machine can do. And sometimes they're, let's say, low likely scenarios with high impact. Those are the ones we're after. High impact scenario, if it is to be a low likely scenario, right, we have to make a decision. Do we have to prepare for that or not? And just lately, since this is a rather new tool, we applied it to an actual investment plan. So we ran the probabilistic load flow also on a case that had been traditionally studied and augmented the information of the probabilistic study to that. So we feel that this is becoming now a reality. It can be used and it's reasonable in time, and you're ready for other people to use it and make use out of this tool.
Okay. Well, that's fantastic. And I can see, because we've known each other for some time, how you're using pieces of what you've learned over the years about the GPUs, the AI, the probabilistic techniques, pulling all that in to solve a pressing problem that utilities are facing all over the place. And so many times the utilities are put in a very difficult position, like you said, to make decisions that are going to impact 5, 10, maybe 20, 30 years down the road. How do you make a reasonable choice? We're not going to get everything right? We don't know what the future holds, but how can we show to the public, to the regulators, to ourselves that we're making reasonable choices for and there's a science basis for the decisions. We're not just like, well, we want to upgrade this substation because it looks old. Well, that's not a good reason. We need to upgrade substations because the actual load flows there, and obviously the aging grid. We'd like to replace everything, but we can't afford to replace everything. So we got to make good practical decisions on where those dollars are going.
Yeah, that's exactly right. The investment decisions are not simple, so we provide other technical points for the decision makers to consider. And these points are not fiction anymore or imaginary, right? They can be calculated. And that's the important part. As you said, we cannot predict the future accurately as if you would have a crystal ball and see exactly how it will be. There are too many unknowns at this point. We have obviously data centers coming in the utility base now. So that's a very big
wild card.
It's a, to say the least, yes. That is an aspect, right? We have to consider in the future of new technologies that might change the equation from what we think today it is. Let's say battery technologies could become more efficient, right? Maybe households can in the future have their own battery. We don't know yet, but if that's the case, right, we would have to remodel and resimulate and make sure that we have that outlook in the future.
Yeah, that's a fascinating idea, and I want to talk about the future as well, because you have an interesting perspective, right? You're getting all of this input from so many sources. You're doing the calculations. You're seeing the output. You're seeing the decisions changing now because of the data and the information you have, which is all going to serve us better. You've got the challenge. Every time I hear about load growth, it's really those two big. It's the distributed energy. It's the electrification of the grid, but also we have this massive data center thing over here, and you're really at the middle of that, right? You're right in the middle of a lot of that load growth, the challenge of that question, and the questions that you're facing, I'm hearing from all different utilities. What are you finding when you're talking to other utilities? Are they doing something very similar? Are they interested in what you're doing? Do they see what you're doing? I mean, it sounds cutting edge to me.
Yes, you meet different people from different utility companies at conferences, and we talk, obviously, and they all are faced with very similar challenges, even to the point that we have established certain, let's say, monthly or quarterly meetings with other utilities just to see, to make sure we're considering what other people might have better ideas on, or vice versa. So you want to make sure.
Is that your own organization, or is that like AEIC or any kind of established organization?
That's your own organization right now.
Okay.
It's more utility to utility conversation, really important. But then you have obviously AEIC conferences. We just had one hosted at Eversource in late September with other utilities coming in and presenting about amazing topics, right? We have not heard about this yet on this talk, but AMI is a big topic. Interconnection automation, how to enable customers to better interconnect with the grid. All of those things play on the distribution grid, right? This is the distribution grid is right now in the spotlight, I think. Transmission has been naturally for years in the spotlight, right? Because there's much more load and generation connected to it. But now the distribution grid is becoming a very well-seen grid as well. And as you can imagine, the distribution grid is not as, I would say, known yet as the transmission grid as far as the future goes. So that's where we do all
there's so many pieces. You can see why using these machines to help us take those thousands or millions of inputs to pull that in and to be able to make decisions is so important. So let me just quick ask about, really from your perspective, the future. You're collaborating with different utilities. You've got a tool. It's working. It's starting to impact the decision making that you're doing there at Eversource. So what's next? Obviously, you're going to continue to work on this, but what are some of the things in the future that you think are going to be the next challenge that you're looking at, either in this particular case or maybe another area that you think your team will be working on?
Yeah, I think I have to look also to some other teams and give them credit on their very specific efforts. But I think, as I mentioned earlier, most of the systems are not perfectly interconnected yet or integrated with each other. There could be one great system that does what it needs to do in a really amazing way, but other systems don't benefit because it cannot exchange information. So that's what we're working on. We're trying to build pipelines to other systems that already have great information and share that. So it's a lot about data pipelines, source data. Eversource is a utility that decades back were many different utility companies. Some of the data is not harmonized with each other, but obviously we can now with software easily harmonize data and bring it together. So IT is doing a great effort here. They have a enterprise data platform where they try now to put all of this data in an organized way and make it available to the end users, which in our case the engineers are, so we can work with data, which was not always a given in the past.
Yeah, how important is it for you when you're looking at a new tool, new software? You have this MATLAB and this D&V tool. How important is it that these systems can easily talk to each other and transfer data? Is that in hierarchy of your decision making of looking at a tool like that from a utilities perspective?
Yeah, that's a very good question. First of all, it needs to be secure and cyber secure. Utilities have critical infrastructure, protection, and we need to make sure customers' data is very secure. So the tools need to be secure. They need to live in an enterprise environment. So whenever we select tools, right, that's one of the first considerations. But then also they need to be able to integrate to other systems. There need to be all kinds of mechanisms that you can integrate. And then lastly, which is the most important aspect to engineers, you need to be able to have control over the solution, right? If you have the source code, if you can work on the source code, if you can change the source code and manage the code and therefore continue to build up the solution, that is very important. So black box solutions are not preferred at all. If there's a solution that's closed, that the end user does not have a certain degree of access to, it's very difficult to have this as a long-term solution that lives, let's say, for a decade in an environment, right? And obviously everybody knows at some point change needs to happen and you need to be able to have that control.
Got it. Okay. Well, I have a couple other more simple questions for you that I ask all of my guests, really about what is one thing that you've learned in the last year that you'd like to share with the industry? Is there something that you learned? It could even be some small tool, trick, idea, something you'd like to share with the industry in the last year.
So especially working in a utility, I think it's pertinent to work closely with the IT organization. I think IT really enables engineers to run and develop their solutions if they're compliant. And that's something what engineers are sometimes not used to. So that is I would say, a soft trick to make sure whatever engineers do, you have the end in mind, that your work is eventually becoming an operational tool or solution that others can use as well. So too many solutions in the past, not just at Eversource, have been started great things and then they died because they couldn't be integrated, they couldn't be used by other people. And we want to make sure that if we put some time and effort into something, that it benefits for a long time. So being more efficient. As far as tools go, I think large language models, right? They are everywhere now. If you look, for instance, to Microsoft's products or ChatGPT, right? There are many, many out there. I'm not endorsing any of those tools in particular, but make sure you can actually write your bots also for the applications that you buy. There are many applications now out there that you can buy over the counter that allow a bot, an LLM-based model to run inside those applications. Companies go towards that. I was recently at the conference, at the D&V conference, where they introduced one of their products that actually has an AI-powered model running inside. See, then technology becomes very powerful. Difficult data, difficult operation of a tool becomes simple. So actually, many engineers can work on a tool and not just engineers who have years of experience. And that is very important. Whenever AI can be implemented in any system and any tool, this is, I think, an accelerator for success in the future.
Wow, that's a great tip. Thank you for that. And that also probably answers my next question, which was really, what's one technology, a specific application we should be watching in the next year? Probably more of that, or did you have something else in mind?
The market is full of amazing technologies. I still look to the ones that can be best integrated and doesn't have to be the best in the world, but it needs to be top 80%, easy to integrate, easy to work with. People intuitively can get used to technology, especially looking at many young engineers coming from colleges or just a few years of job experience before they enter the utility. Within a year or two, I can see some of those folks being ramped up to a level that is unbelievable, right? You give the right people the right tools, and you make sure they do everything in compliance, and you have great results. First of all, people feel proud of what they can achieve, and second of all, the value of what they have done is benefiting not just the utility, but eventually the customers. So,
well, you bring up young people getting into our industry, and this is a passion of mine. I know it is of yours as well, to mentor folks. So what would you tell someone? What tip would you give someone who's trying to get into our industry? Where would you start? What tip could you give them to make a start in our industry?
Very good point. If you go into utility specifically or utility-related industry, as you and I know, where we have worked earlier, I would say understand the fundamental power system technology first. Nowadays, it is amazing what resources you find, and then also work with it in a little bit of a programmatic way. 10 years ago, that was much more difficult. Nowadays, you have these amazing technology at your fingertips where you can work with data. You can work with power system simulation in I would say, prototype environment to further get comfortable with power systems. Work with somebody who's more senior.
A mentor.
Work very close with a mentor. Ask questions. Never think questions are a sign of weakness. They're a sign of strength. Try to understand.
Curiosity.
Yes, exactly. And continue your journey, because new technologies come in. Even the seasoned engineers have to adapt to new technology. So I think eventually it becomes everybody can mentor people and talk about technologies for the benefit of technologies enabling all the challenges we have to solve.
Well, that is a great tip. I love it. It makes a lot of sense, and I can tell that you're passionate about helping the industry get there. And even though you and I are not the young people anymore, I hope we do better than the previous generation in adopting good technology and keeping an open mind. So, and I know that's who you are. It's really been great to catch up, Steffen. There's so much we could cover in addition, but I just want to say, is there anything else you'd like to share with our audience before we conclude? To closing remarks.
No, I think the utility world is very rapidly changing right now due to AMI. Some utilities have fully embraced it yet. We are just at the beginning. All the data tools that are coming in, right? Utilities are a trough of amazing large-scale data. All of that can be easily structured and made available to utility engineers. AI coming in very different forms. I can see it already now how our engineers who are allowed to use AI at Eversource, how they thrive to cut certain side tasks off by having AI helping them and really focus on the solutions rather the means to prepare to solve the solution. So it's a really exciting time in the utility industry. And obviously, I think the journey in the next 5, 10, 15 years will be amazing because the grid will completely change. the behavior of customers, right? We have to continue to do best due diligence to keep electricity affordable, safe, and reliable.
Right. Well, I'm happy for you, Steffen, in your role. It sounds like a really exciting opportunity for you. And I'm really excited to see some of the things that you used to tell me about over maybe almost a decade ago, about AI, about machine learning, about the probabilistic. These were all things that you were thinking about and researching so many years ago, and you're implementing, and now you're teaching others, and you're helping the industry move forward. Steffen, it's been fantastic to catch up. Very exciting time, and appreciate you spending some time with us today.
Thank you so much, Ben, for having me. It was a pleasure.
You're welcome.
Take care.